Alright, so let's take a look at indeterminate forms and L'Hopital's rule. I saw a t-shirt over the weekend that said it's all fun and games until somebody decides to divide by zero, which I thought was kind of neat. And it's kind of funny because we're always told you can't divide by zero, and you really can't, but with limits we can do some pretty interesting things. Let's say that we had this limit here. The limit as, let's say, x approaches 0 of the sine of x over x. And so in Calculus 1, you're taught that if you have sine of x over x, you have to use this special formula. Or it's always equal to this, but you're not told why. You're just told, just use this. Okay? And so this, if we were to let x be 0, then this would be in the form 0 over 0. Right? But it's not equal to 0 over 0. It's actually equal to something. And in Calculus 1, when you start talking about limits, if you work out a limit at infinity of, say, 3x squared minus 1 over 2x squared plus 1, then you're taught, well, divide everything by the highest power of the denominator, right? So you're taught to divide everything out and then let things go to 0 that are being divided by x, because x is going to infinity. And you're told to find an answer that way, which is okay. It's just methods of going through and evaluating limits if you can't do some of the tougher calculus. All right, but what form would this be in if we just plugged infinity in? This would be infinity over infinity, right? If we just plugged infinity in. Infinity squared is infinity times 3 is still infinity, minus 1 is infinity. Okay? So these two indeterminate forms are the first two that we cover. All right? And these two indeterminate forms are actually the two forms that we're going to try to get almost every other indeterminate form that we work out into. There's going to be some kind of trick where I can do something and then change it, eventually change it into 0 over 0 or infinity over infinity. And the reason why we want to do that is so we can apply something called L'Hopital's rule. All right? L'Hopital's rule is pretty cool because it explains things like this that you were just told in Cal 1. It just always equals this. Don't worry about why. Okay? And what L'Hopital's rule says is that if you can get the expression that you're taking the limit of in the form of 0 over 0 or infinity over infinity, then the limit as x approaches c, some constant c, of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. So it explains something like this first limit right here. Since it's in the form 0 over 0, then this is equal to the limit as x approaches 0 of the derivative of sine of x is cosine of x. And the derivative of x is 1. So now if you let x approach 0 or equal 0, you get the cosine of 0, which is 1. So that's why in Calculus 1 you're told that the sine of x over x is just equal to 1. Just deal with it and remember that. Well, it's because it's in an indeterminate form, which we can apply L'Hopital's rule to and get the answer. And so on this second problem, you were told to divide everything by x squared, which is okay. It's a good method to go through. But what we can do is we can say, okay, well, this is equal to the limit as x approaches infinity, and then take the derivative of the numerator and denominator. You'll get 6x over 4x, and then this will still be in the form infinity over infinity. And so since it's still in that form, we can apply L'Hopital's rule again. So that's equal to the limit as x approaches infinity of 6 over 4, which then there's nothing to plug the x in for, so that's just equal to 6 over 4, which is 3 over 2. All right. You can also apply this if you have the forms negative infinity over infinity, or infinity over negative infinity, or negative infinity over negative infinity. So the infinities can be positive or negative, it doesn't matter. All right. So it either needs to be in this form or 0 over 0. And once it's in those forms, then all you have to do is take derivatives. Make sure that after you take derivatives, if you still can't evaluate it, that it's in one of these forms. Because L'Hopital's rule will not work if it's 0 over infinity, or if it's 1 over infinity, or infinity over 1. It won't work then, okay? So you need to make sure it's always in one of those indeterminate forms before you use L'Hopital's rule.